Welcome back, Math for Teachers 2 students. We're going to cover lessons 20, 21, and 22. So we're going to start with lessons 20 and 21, and we're covering the standard division of fractions algorithm. Always make sure that you're looking at your goals at the beginning of each of your submodules for the individual lessons. You can hit pause at any time during this video, again, to read these if you have not already looked at the submodule information. Talking about how to prepare, we're going to think back on how we learned about dividing fractions, and remember your recall about flipping the second fraction. Okay. So as we begin lesson 20, do you know why you were told to do that? So think about, again, go back. Remember, we're scaffolding our lessons as we move forward. Now, I put the recap up front because, again, some of you, college students, and some of your children and students in the future may find it helpful to use the application tools before and after reviewing the lesson. So let's take a look together at this website. Remember, as teachers, it's always helpful to explore new resources, but also take time to review those resources. There may be parts that are specific to what you're teaching, and then there may be other parts like math articles that will be helpful for you to learn how to teach them. Okay, so there's different types of maths, math articles, math formulas, math syllabus, so important questions to ask, and then your math calculators as well. So this one's chock full of different information. Let's scroll down. It's talking about reciprocal and division of fractions, and you can see one of the really great things about this website is that it's highlighting your math vocabulary, right? So you're also learning the process of dividing fractions, parts of the fraction, the numerator and the denominator. It's giving you examples of different fraction types, proper fraction, improper fraction, mixed fractions, right? So good information and reminders, and we'll stop here, but certainly you can go back and explore this some more. Again, really be thinking about, is it beneficial for your students to have this information before the lesson, or is it truly a reinforcement and a tool they could use after it's taught in the classroom? Okay, so multiplication. For the general multiplication equation, what do each of the letters usually tell us? A times B equals C. So let's take a look. A is going to tell us the number of groups. A tells us the number of groups times B. B tells us the size of each group. And then C, write it down or think it out loud, tells us the size of the whole group. So A, number of groups, times B, size of each group, equals C, the size of the whole. So far, we focused mainly on the repeated fraction or measurement model of division. So for measurement meaning, what do we know and what are we trying to figure out? You can go back and look at the previous slide. C divided by B equals, so let's take a look. Whoops. So here we're looking at the measurement. We're trying to figure out how many copies of one group, the divisor, fits into the whole group, the dividend. So C divided by B equals. Do you know which one is the divisor and which one is the dividend? Again, that website might be helpful to tether back and forth to. So again, so far we focus mainly on repeated subtraction or the measurement model of division. For the measurement meaning, what do we know and what are we trying to figure out? We know C is the whole, B is the size of each group, and then our solution is going to be the number of groups. So for measurement, we're trying to figure out how many copies of one group, what? What are we going to uncover here? For measurement, we are trying to figure out how many copies of one group the divisor fits into the whole group, the dividend. Okay. I know these slides seem repetitive, but again, want you to remember that repetition is really important. Thinking about what tools that you're providing your children, whether it's a worksheet, right? Fill in the blank, whether they're following along with overhead projector slides or smart boards. We're going to talk about partitioning. So partitioning is equal sharing, the meaning of division. So partitioning, meaning of division. What do we know and what are we trying to figure out? 4 divided by 2 equals, this one is typically a little bit more straightforward. So 4 is the whole, 2 is the number of groups, and what we're finding out is the size of one group. One group. 4 is the whole, 2 is the number of groups, and we're finding the size of one group. So partitioning, we're dividing the whole into a known number of groups, trying to find, the size of one group. Okay, see here how I have highlighted your dominant vocabulary, your focus words in red here. So in this equation, we know that 4 makes up 2 groups, and we're trying to find the size of one group. You might want to write these sentences out as fill in the blanks for your children, right? You might want to handwrite them out or have them type up. There's lots of technology tools where they'll self-generate. For partitioning or equal sharing, meaning of division, what do we know and what are we trying to figure out? A divided by C equals, so again, C the whole, A the number of groups. What we're trying to find is the size of one group. So for partitioning, we're dividing the whole into a known number of groups and trying to find the size of one group. Remember, you can hit pause at any time. Sometimes it's helpful to write things down. Are you that person that needs to write C divided by A equals, C is the whole, A is the number of groups? What we're finding is the size, and maybe you need to write down your own equation, right? Maybe that helps you solidify it. For partitioning, meaning the division of fractions, the meaning is the same, but sometimes the divisor is the only part of the group. Okay, so again, 4 is the whole, 1/2 is the number of groups, and we're trying to find the size of one group. So with this equation, we know 4 makes up half of a group, 4 divided by half, and we're trying to find, say it with me, the size of one group, right? So start to see the repetition. When you're trying to find aligned children's literature, we always know rhyming and repetition is helpful and kind of clicks into the children's memory, right? Okay, so recap of lesson 20. And again, the reciprocal and division of fractions, that's that same website that we looked at the beginning. So is it helpful to go back, reinforce what we've just gone over, or are you feeling confident? If we were in the classroom together, we would do thumbs up, thumbs in the middle, thumbs down. Be honest with yourself. And if you need to hit rewind and watch this again, you certainly can. We're going to venture into 21, always looking at your goals. So hit pause here and take a minute to read. In preparation, we know that in lesson 20, we began to develop an understanding of why the invert of and multiply strategy works when dividing rational numbers. And in this one, we're going to, in lesson 21, we're going to develop a model explanation. Okay. Let's take a look. You'll need a piece of paper and a writing utensil. So again, you might want to hit pause here and grab a pen, a pencil, and paper. Okay. So we're going to fill in the blanks for each of parts of this algorithm. 1 1/8 divided by 2/3 equals. Let's take a look. 1 1/8 divided by 2/3. 1 1/8 times 2/3. Now we're going to explain the steps. Okay, so think about what your next steps are going to be. Okay. So to explain the steps, the meaning of 1 1/8 divided by 2/3 is to find out how many copies of 2/3 fits into 1 1/8 basic measuring units, BMUs. To do this, we first need to figure out how many times 2/3 fits into 1 BMU. As the algorithm below illustrates, 2/3 fits into 1 BMU 1.5 times, or 3/2 times. So let's take a look. Okay. So 1 BMU, 2/3, the shaded regions, fits into 1 BMU one time with one of the pieces left over. So let's break it out a little bit further. We've got 2/3 with the leftover of, right, 1/3. Okay. In the slides posted on D2L in the submodules, remember these illustrated boxes won't be there. So if you prefer a straight look at the slides, this video will be posted. These slides will be available. You can manipulate these as you go through, okay, if that's helpful. And they will be boxed out the way it's posted, but you can go in and manipulate these. All right, so let's keep going. Above is what we just went over. And let's take a look here. So the leftover pieces equal 1/3 of any copy of 2/3. So if 2/3 fits into 1 BMU 1.5 times, or that should say 3/2. Right? Right. Good to check your slides, everybody. Here's another one. No, I didn't do this on purpose. So always check, make sure that the equations are right. We're all human. Check your spelling and punctuation as well. So let's start over here. Leftover piece equals 1/3. Right. Or what kind of manipulatives would you use? Fraction strips for this? Would you use unifix cubes? We've talked a lot about different manipulatives. Let's start over. Leftover piece equals 1/3 of any copy of 2/3. So 2/3 fits into 1 basic measuring unit, BMU, 1.5 times, or 3/2 times. We now know how many times 2/3 fits into every BMU, every 1 BMU. So now we all know all we need to do is to figure out how many times 2/3 fits into 1 1/8 BMU. Why is that? Because 1 1/8 BMU is 1 1/8 times